Thanks for joining us today for the Weather Classroom. It's that time of year when we talk a lot about severe weather practically every afternoon. And so one of the tools that we use to help us look at severe weather is the radar. And today we're going to talk a little bit about Doppler radar, which is a newer form, and we can see the thunderstorms better. You can predict where tornadoes are a little bit better as well, and even get a look at winds with Doppler radar. We'll also take a look at our history segment, which is about Mount Saint Helens. More on that coming up.
Here at the Weather Channel, we're constantly showing you radar images which indicate precipitation. You might wonder how radar works. Dennis Smith explains.
Weather radar operates very much like radio in that it transmits and receives radio signals. The difference is that the transmitter and the receiver are in the same location. The radar sends out a beam of radiation that has been calibrated to reflect off particles the size of raindrops, snowflakes, or hailstones. When it hits this precipitation, it is reflected back toward the transmitter. This return signal, or echo, shows the radar operator the distance and the strength of the precipitation. In the field, the echoes on a radar scope are not easy to interpret. So for television, radar presentations have been digitized and enhanced. This is done by assigning different shades of gray or color to different levels of echo brightness. For example, this radar has been enhanced to show light rain as a light green color. Moderate rain is darker green. The yellow and orange areas are heavy precipitation, the kind you might find in thunderstorms. With the addition of map grids, you can see where the precipitation is falling in relationship to where you live.
Nowadays, we have the added advantage of Doppler radar. Doppler helps us better determine the motion of wind in a storm.
The Doppler radar dominates the skyline at the National Weather Service office at Pleasant Hill, Missouri. The radar, since its installation, has been a tremendous benefit.
It's helped us in snow and ice situations, in heavy rain situations, severe weather such as damaging wind events, large hail events, tornado events. It's just an amazing piece of equipment.
The Doppler has enabled the office to produce more accurate forecasts and issue more timely warnings when severe weather threatens. The radar paid for itself the first time it was called into action.
The old radar gave indications that the snow was tapering off, that this event was about to end. On the other hand, the Doppler radar said that no, it's not about to end, it's about to get worse.
The Doppler proved to be correct after the area received another 4 to 6 inches of snow. The radar aids in all types of weather situations. This particular storm shows a developing thin blue line, a gust front.
By seeing the storm structure, the person in front of the radar knows that this storm is one that is extremely dangerous and one that has to be watched very carefully.
The more Doppler radar installations, the better. Improved technology means more warning, which in turn allows people to be better prepared. I'm Dennis Smith, the Weather Channel.
As mentioned, today's focus dealing with radar, and here's basically how a radar unit works. It sends out these pulsations, and once they actually interact with the precipitation contained within the cloud itself, it'll send them back, and we use the range height indicator on the radar to really get a good idea of how far away these actual radar echoes, as what we call them, are, how far they are away from the actual radar site. Sometimes, though, you may see a situation where you'll see these big storms out maybe, say, 150 miles, but these smaller storms, the showers maybe in the foreground, are actually not seen as you overshoot these tops, as you catch the pulse up in the higher clouds, but not in the nearby clouds. And again, with the impending severe weather season, we definitely need the radars. We talked about the Doppler radar capability not only to pick up the precipitation, but also to pick up the field of motion with the wind, and you can actually detect the rotation within the actual clouds. And you can see over a given week, we really need that Doppler radar. Check out this now, tornadoes by month. The highest incidence is in May and June, so I'm sure Doppler and NextRad radar will be working overtime the next few days. We'll touch base with the answer to the question right now.
14 years ago, on May 18th, Mount Saint Helens erupted, sending smoke and ash miles into the sky. For today's history segment, Dale Eck takes a look back at that powerful eruption.
On March 20th, 1980, after being dormant for 123 years, Mount Saint Helens was awakened by an earthquake. For the next 6 weeks, emissions and small earthquakes beneath the surface raised fears of a major eruption. Then on Sunday, May 18th at 8:39 a.m., the mountain blew its top. Smoke and ash catapulted into the air 13 miles high.
All of a sudden, the whole sky just filled with smoke and debris, and it was very interesting because it had little round balls of lightning bouncing back and forth up there.
The explosion ripped 1,300 feet off the top of the mountain. Within minutes, 57 people were killed, and everything in a 150-mile radius was devastated. Tons of ash fell onto communities. In Yakima, day turned into night as ash blocked out the sun. Visibility was near zero for 12 hours. The eruption caused mudslides and flooding. Rivers of water became rivers of ash. Homes and bridges were swept away. Did the eruption have an impact on weather patterns?
No, I don't think it did, although Mount Saint Helens was a fairly impressive volcanic eruption. It didn't spew the kind of materials up into the stratosphere that previous volcanic eruptions have done, so the overall cooling of the Earth was minimized here. So it may have had a slight effect, but I don't think it had as much of an effect as, say, Mount Pinatubo did.
Today, Mount Saint Helens is silent, but some experts predict that within 100 years, another eruption is possible. I'm Dale Eck, the Weather Channel.
The Weather Service is constantly improving the radar system all across the country. Let's take a look at some of those new systems. Major improvements continue to occur within the National Weather Service. One of the most important is the implementation of state-of-the-art weather radar. This next-generation Doppler radar, known as NEXRAD, is currently being deployed nationwide. As of December 1993, approximately one-third of the nation has this Doppler radar coverage. By the end of 1994, the National Weather Service plans on having nearly two-thirds of the country covered with the new radar, with nearly complete coverage anticipated by June 1996. The capabilities of the next-generation weather radar are enormous. Until now, conventional radar could just show precipitation. However, Doppler radar will give us much more information. For instance, the new technology enables forecasters to estimate amounts and types of precipitation. Doppler radar should dramatically improve both the lead time in forecasting severe weather and the tracking of potentially severe storms. What you are looking at is a NEXRAD product that distinguishes between moist air parcels flowing towards the radar site versus parcels going away. Green indicates movement towards the radar site, red away from the site. A signature of a possible tornado is an area where bright green and bright red are adjacent to each other, as highlighted here. You're seeing the actual radar signature of the tornado that hit Red Rock, Oklahoma in April 1991. This multifaceted radar is proving to be invaluable in its ability to alert the meteorologist and, in turn, save lives. Bill Keneely, the Weather Channel.
Join us tomorrow on the Weather Classroom when we'll be talking about the upcoming hurricane.